Changed it.
All right, so I'm going to share my screen. You out of the way. All right. So we talked last time about data transformation techniques and one package really in particular called dplyr. And so I'll kind of just be going over a couple more functions from dplyr in this one. I want to do a little review first. So we talked about the different data types, and I want to see if people want to just popcorn out a couple that they remember from the last visit, or just no. Looking at Nate on the just no.
Numbers.
Max, it's up to you.
Yeah, let's see. Variables jump out as a data type.
You're thinking back to one lesson before this one. So this was the one from last time that were like character, numeric, integer, logical date. Basically the different like types of information that can be stored in a variable.
Gotcha.
And then I pretty briefly last time talked about data structures, but they're important. And this is just a list of some of the common ones that you use in R, or when you're especially working with tabular data. I
have a question here.
Yeah.
This is one of the things that confused me about R for a long time. And that's, what is the difference between a vector, an array, and a list?
Nate, I think I know the answer to this one.
Okay.
A vector is when you have several different things that are all the same type. So if you have 1, 2, 3, but if you can have different types in the same vector.
You couldn't have a 1 and a string, say.
Right. But an array, so then it goes to a matrix, which is where you have a bunch of columns and rows of vectors that are all the same type also.
Mm-hmm.
And then an array is just a 3D matrix. So yeah, so it is a cube basically in terms of data structure. And then a list can have any type be an individual item in the list. So it's different from a vector in that like you can have a list of vectors, but that list of vectors could also have strings and numbers in the same list.
Right.
Yeah.
And then data frames and tables are really similar, but tables are like better.
Right. They're very similar. And I think the differences are just like pretty esoteric, and the preference is just to use tables for tidyverse, because tidyverse, or they've been like optimized to work with all the different tidyverse stuff.
Thanks.
Yeah. And so read CSV is the one that we talked about and have seen a couple times, and it reads in your CSV files. So you get your data into your working environment. Write CSV is what you use to save your CSV file back to your computer.
Okay, one more question. I'm sorry, I'm going to interrupt again. I've also seen read.csv. Is that the same or is it similar?
Same. No, not same. Similar.
Okay.
It read.csv. So oftentimes there will be dot and underscore versions of the same function. And the dot ones are the base R versions, and the underscores are the tidyverse versions.
Okay.
So yeah, so if you didn't load tidyverse, you won't be able to run read underscore CSV, but you would be able to run read dot CSV. But read underscore CSV is supposedly a lot faster for reasons that I don't understand.
Cool.
Yeah. Rename will rename your columns in your table. Select specific columns from a new and form a new table. And mutate will create new columns. So all those are pretty basic functions, but they're very general, meaning that you can do a lot with just those sort of simple basic functions. I wanted to talk about pipes, which are one of the things that people love about the tidyverse, and a super handy operator. So we talked about operators before, in that they're simple functions that usually just take one input and give one output. The plus sign is another operator. And the pipe operator comes from a package called Magritter. And it allows you to take the output from a function and forward it to the next function without having to save it as a variable. And so we'll see that in a sec, how much that can save you. And so by making your code more concise, it can make it less error prone, just because you're not saving off a bunch of variables and then overriding things or misspelling your variable names. So we can open up RStudio. If you have it handy, you can open up two. This is the folder that comes from the class 3 folder on OSF. If you here, I'll drop the link to this in the chat in case you want to have them for yourself to look at. So the homework file from last time could be answered in probably a couple different ways, but I made my own answer so that we can walk through them. The file should be set up that if you just click on the file, the R file in that folder to open R, then it will set the working directory as that folder, which will allow you to use all of the files. But as a heads up, Heather, especially if you open R before and then try and open the file, it will have a different working directory and the files will not load well. So loading in the tidyverse, we just use the library tidyverse. The next step is to read in our CSV file. So here we're reading in the small df.csv, a small iteration df.csv file. If you had taken out that file, it would still work. The next thing is to rename a couple of variables that were not in snake case. And so you'll notice that here I had to put the MBI type column into quotes because there's a space in them. And if I didn't have that, like with age, it's okay to not have quotes. It would think that MBI is the variable that I'm trying to reference. And so then it would break the code. So you're in these first couple. Loading in tidyverse, and then we get our df for our data frame up here. And we have that MBI type column. So you can see that this line, when I run it, it changes it now to snake case. There's another function that you can use if you don't want to be clicking around and looking at the full data frame. You just want to get a quick look at your tibble. You can also do head and then the name of the tibble, and then run that, and then it will print out just the first 6 lines of the tibble and then the column names. So it's just, you can also change how many it outputs on that with a parameter. So the next one is to log transform the attrition data. So here, use mutate to create this new column called log MBI attrition, and just use the log function, which comes from base R, to transform this whole column. And so you can see that this has log transformed the data. Logging zeros doesn't work, but we're not going to worry about that. The next one is a function that we hadn't gone over yet, but the function that you'd want to use in order to order your data from high to low is arrange, and then you have to use this descend function inside of arrange in order to get it to go from high to low. Otherwise it would have gone from low to high. You can see if you get rid of that, it defaults to having the lowest first. The last one just plots the data. You would have had to change the names a little bit from the past ggplot, and since we haven't really gone over that, I wouldn't necessarily have expected everybody to know how to do this one. But you can see just visually that when we log transform it and now plot the log, it looks, it's not skewed like it was in on the I guess last time that we visualized the data, and you get your line here, which tells you that maybe there's a little bit of a relationship, but you're not doing any statistics to actually see if that's significant. So you can see that when do all of this, it ends up looking like a lot of code to do really not a lot of work. I did pretty heavy commenting in here, which is a good habit to get into, but you wouldn't want to necessarily put that much commenting in your own work. Does anybody have any questions on either homework if you did it and ran into problems, or just when I'm going over this, if there's anything that was stood out? Great. So if you open up this class 3 pipes file, you can see the magic of pipes. And so this is, I took out a lot of the comments, so it looks shorter in part because of that. But this is the same, this code does the exact same thing. And it's in 2 different versions, but you can see that much code is all you need in order to do everything that all of that code does. But when you're using pipes, you have your first function, and there you've told it what data frame you want to use as input, so df, and remember in the tidyverse it's almost always the first position that will be your data frame. And then it with the pipe, it forwards the output of this to the next function, which is mutate, and then you don't have to say which data to use because it knows take the data from the output here. And so then you can pipe that onto the next one. And so if we look back at our original, we had to put the data frame in for each of those. We had to save it as df, which is overriding that variable every time. And that kind of opens up just extra places where you could have a bug sneak in. The way some people say to think about pipes when you're learning it is to think of it as saying like, do whatever the first function is. So do a rename and then, so the pipe means and then. So do the rename and then mutate and then arrange is the way to kind of read that when you're trying to think through what it's actually doing.
And am I right in thinking that pipes will work in any case where the first parameter of a function is the data it's supposed to work on?
I think that that's true.
Yeah.
I think I know I've run into problems using like older functions or like base R functions with pipes, because I'm not sure if that's the reason, like maybe because the data parameter is a different one, but it works very well in the tidyverse. Outside the tidyverse sometimes runs into problems.
Okay.
And then you can also see that the very last one ends up, in this case, getting saved as the variable there. And if you really wanted to, you could even have piped everything from read CSV to your plotting. And then you never even have to save a data frame, or you never have to save a variable of it. And it will still work. So your environment's empty, the data, but it still does everything. Pause for questions on pipes.
Your description of pipes was really clear. I appreciate it. One thing I don't understand about that code was, would you actually need to rearrange the data to do this plot that you want to do? Does it have to be sorted?
No, it doesn't have to be sorted like that. That was just part of in that homework assignment, was just like a thing to, if you wanted to look at it.
Gotcha.
First, yeah, in order to see who like the top highest attrition studies were.
Thank you. There are some weird things in SAS where you do have to sort the data before you do certain things. So good to know you don't actually have to have it sorted in any particular way.
Yeah, the only time I'll say that you might run into something like that is when you're plotting sometimes when you're plotting numeric things, you'll want to change it to a factor in order to plot it. But I don't want to get into it because I will explain it.
Out there.
Yeah, the other place where you might have to sort, at least you do in Python, is if you're doing a group by.
Okay, right. Thank you. And you would do that with arrange just in a
grouping
variable?
I don't know, actually.
I think you can do. I don't know of a situation where I've had to arrange it before using a group by in
Nice.
R. But speaking of group by,
Yeah, you're right. It doesn't look like it requires that at all. Nice.
Yeah, that's good to know.
Thank you.
So these are the other 4 functions I wanted to cover today. They are, I think, all still in the dplyr package, which is part of the tidyverse. And filter allows you to subset your tibble based on conditional logic. So if you wanted to only see the rows where people are 65 years old, then you could set it to only show you those rows. Arrange, we just covered basically, but it allows you to arrange your rows based on the values in one column. And I think that you could do multiple, and it would arrange them in order of priority of the positions that you have them in the parameter list. And if you want to have it go from high to low, you have to use the descend or the DESC. Summarise allows you to make summary statistics for columns, and it will produce 1 row for each group and 1 column for each type of summary stat that you input. So you might want to find the mean or the minimum maximum of a column, things like that. And if you want to change which groups it's calculating those means for example, then you would use group by in order to calculate the mean within the groups rather than the mean for the whole data frame. And you also will want to do ungroup after each or when you use group by, because it's really easy to forget that you've done group by on something and then other functions end up doing weird things. Hey, Robin, feel free to hop in if you have any questions at any point. Those are my references for all my pictures. We'll go back to looking at R, where for our last file, I just have a couple examples of those functions in action. So say I was taking the same data frame and I wanted to, I was curious which columns have the highest attrition, or which rows have the highest attrition. So this is the same code from the homework, so that I can look at it and see that this Olympe 2020 study had the highest attrition. So 79 people dropped out of the study. And you can also see that with the log. And that was in the mindfulness-based cognitive therapy study. So my hunch would be that MBCT might be the type of mindfulness intervention where people drop out the most. I'm curious if that how that actually relates to the overall average. So first I'll look at MBCT. And so I'm using filter here on my data frame to select the MBI type columns, the rows from that column where MBCT is the value. And you can see that I had to use the double equal sign here because that's how we show that something is equaling rather than assigning value to something. So get filtered, so it's just MBCT, and then look at those. And you can see that MBCT studies do definitely have pretty high attrition. The overall mean for every study I get by using the summarise function here to just select the data frame again, and then choose which statistic I want to calculate. So here we're just going to do the mean of the attrition column, save it as average attrition. And so since we only have one group and we only have one stat, we're just getting a 1-by-1 tibble where we see that the mean attrition overall is 10. So that MBCT study that had 79 people drop out is definitely a lot more than mindfulness-based interventions in general. But it might not be that on average MBCT has the highest just because it has one that's the highest. So if you want to break out your means by group, you would use group by here in order to group by MBI type. And so I think there's 6 MBI types in this data set. And then you do summarise so that it knows to calculate the mean for each type of mindfulness-based intervention. And you can see that I did this a little differently here, where I started with just the data variable, and then I piped that into the first function. That's a pretty common way to use pipes, and I actually say probably more people do that as their just like standard way of using pipes. I think in part just because it makes it really obvious which data you're working with. And so when I run this, you can see the 6 different types of MBI that we have. The mindfulness-based cancer recovery is actually the highest on average. If you look closer into the data, you see that that's because MBCR only has like 2 studies in the whole data set, whereas MBCT has like 40. But we're not actually caring about attrition right now. And that just gives an example of how you could use all these different functions to ask questions about your data if you're trying to just poke around and figure things out. It's also now all in one script. So if you wanted to run it all, and you could even add a line to output, the MBCT or the MBI average attrition data frame, and then it will work the same every time you run it. And that bringing it back to the beginning of these sessions is the huge advantage of doing it over Excel, because if you had looked at all those things in Excel, you would not be able to run it again after you've gotten new data. So that is everything that I wanted to cover for today. Does anybody have any questions or anything about any of that? And if no, I'll just plug that we have the OSF page, which has the different classes with their folders that have all the data and scripts in them, and also the slides. And then the wiki is running slow, but has some homework if you want to do it. Today the homework's more loosey-goosey, but just to download the files, look over all of the scripts that I wrote, and then create your own code to summarize different aspects of the data from the data set that we have, and ask your own questions, like what are the oldest and youngest people in the data set, or studies that have the oldest and youngest average age, things like that. Or you could also import your own data frame from your own work and try asking some of your own questions. Max, you could try and figure out who Richie meets with the most. And there's also a feedback survey, because we love data. So if you want to give me any feedback about how today went, there you go. All right, I'm going to stop sharing unless anybody has any hot insights to share before the end.